We're going to be asked to simplify pure imaginary numbers and to work with them, but before we do that, I'm going to go into how we derive this imaginary number and the rest of the patterns that go along with imaginary numbers. So the first thing we have is that I is defined to be the square root of a negative 1. So if we want to define what I squared is, what we'd want to do is we want to be able to take our first one that we define, I is equal to the square root of a negative 1. So then if we square both sides, then I could get I squared equals, and squaring will undo the square root of negative 1. So what we have then is that I squared is identical to, or defined to be, negative 1. We want to keep building off this, so we want to get to an I to the third. And I want to show you that I can build an I to the third by knowing what I squared is. I already know that I squared is equal to a negative 1. And if I want to get to an I cubed, I'd want to multiply both sides times I. This would give us an I cubed, using your power rules, times a negative, or negative 1 times I is a negative I. So that's what I cubed is defined as, is a negative I. We want to keep building and get to I to the fourth. Well, to get to I to the fourth, I simply use the value of I to the third. We have defined I to the third to be equal to a negative I. To get to I to the third, I'd want to bump it by taking it times I. So that would be I to the fourth would equal a negative I times an I is a negative I squared. But keep in mind that I squared was defined earlier as negative 1, so it's the negative of a negative 1, or just a 1. So I to the fourth is equal to 1. Okay, so then we're going to continue to press this pattern a little bit farther, so let's go I to the fifth. I to the fifth, we can define I to the fifth by knowing what I to the fourth was. And I to the fifth is equal to an I to the fourth times another I. But I to the fourth is equal to 1, so it's 1 times I. So it is just I. Then we're going to look at I to the sixth. And I to the sixth could be thought of as I to the sixth could be thought of as I to the fourth times I squared. But I to the fourth is equivalent to 1, and I squared is equivalent to a negative 1, so it is also equal to a negative 1. And we'll go back to I to the seventh. I to the seventh could be thought of as like I to the fourth, then times an I cubed. I to the fourth is 1, and I cubed we already have defined as a negative I, so 1 times a negative I is a negative I. And then we're going to go one more, we're going to go I to the eighth. I to the eighth is equal to I to the fourth times another I to the fourth, or 1 times 1, or if you want, an I to the fourth squared is another way of thinking it, but it's a 1 squared, which is equivalent to 1. And we see that this cycle repeats itself over and over. Every fourth time we'll be back to a 1. Every fourth time will be to a negative 1. If we start at the 2, if we go down 4, we're going to be at another negative 1. If we go down 4, we're going to be at a 1. So it's a repeating pattern of 4. So with that in mind, we should be able to simplify larger and larger powers of I, and that's what our first task is. And a lot of this is simplified, or at least explained, in the textbook here and in the writing on what I just did there. There are two basic ways that you can try to simplify these. I really kind of lean towards one method over another. I believe it's a lot easier to follow and it's less complex. So I'm going to look at doing this in one way. If you want to look at your book, there's another pattern there that you might want to look at too. We're going to start off with I to the 53rd. When we simplify these, you should never have anything larger than I to a power of 1. So keep that in mind. If I got an I to the 53, I got to boil it down to an I to the first, or just a 1, or a negative 1. It shouldn't be anything bigger than this pattern of 4 that we have. So the biggest thing that we think about is, we know that I to the power of 4 has the most value to us because I to the fourth is 1, and 1 to any power, whatever it is just 1. So really the key is thinking of powers of 4. So I'm going to take that 53, and I'm going to see how many powers of 4 are in that by dividing by 4. Goes in there once, 13 goes in there 3 times, that's 12, I have a remainder of 1. So I got 13 powers of 4, and if I do that, that gives me a total of 52. So I'm going to take I to the fourth raised to the 13th, which is another way of saying I got I to the 52. Well, that's not large enough, so I have to multiply it times another I. So we need some flexibility with your exponent rules so that you can make powers of 53 or whatever they give you. Now, as we said earlier, I to the fourth is a 1, and it's going to be 1 to the 13th times another I. 1 to the 13th power is nothing more than 1, which is times I, or all we have is the value of I. So that is the power of I to the 53rd. It simplifies down to I to the first. Okay, now when we run into negatives, they're a little bit trickier, but you're going to use the same concept. When we run into negatives, we want to go a little bit beyond those negatives. So this I to the negative 18, I like to think of it as this. I to the negative 18, I want a power of 4 out of that negative 18, but I want to go beyond. Anytime it's negative, I want to go beyond the power. Whenever it's positive, I want to go below the power. So I want an I to the fourth, and I want to raise it to the first power above 18. So I to the fourth raised to the fourth would be negative 16. That wouldn't be high enough, so I want to go to the fifth, and to the negative fifth. So I've got I to the fourth raised to the negative fifth. It really means I have I to the negative 20. But I want to end up with I to the negative 18, so I need an I squared. And that would be equivalent to I to the negative 18, so times I squared. But I to the fourth is nothing more than 1, and 1 raised to any power, even if it's a negative 5, is still just 1. So it's 1 times I squared. Now I'm going to deal with the I squared. I squared is defined to be a negative 1, so it's 1 times a negative 1, or the equivalency of a negative 1. Whenever you do these simplifying, you'll never have anything more than a 1, a negative 1, or an I, so keep that in mind. So with the negatives, make sure you go beyond your power, just beyond it, and powers of 4. With positive powers, you want to go just under it, so it's a matter of over and under, trying to make sure that you get the equivalencies as close to your powers of 4 as you can.